Good morning, everybody. I'm Doc Moorhead. I've been a senior engineer with the Carbon Trust for 11 years now. A lot of the work that I would do would be on-site energy auditing across a wide range of sectors. So the bulk of the opportunities and savings that we're going to outline during this seminar, I would come across these on a daily basis, and they do represent the most common areas for making significant savings in your compressed air systems. We're going to spend a little time just becoming familiar with the technology, just identifying the main system components. But the bulk of the time I'm wanting to spend on outlining the areas where savings can be made, and look to quantify the scale of those savings. And then, most importantly of all, is to go through how you can access the help and finances with which to implement the projects. So a quick introduction on the Carbon Trust. We're a not-for-profit organisation, and as such, any surpluses from our operations we can then reinvest in the commercial activities with an aim to implementing our mission, which is to accelerate the move to a sustainable and low-carbon economy. To deliver on that mission, there are three areas that we concentrate on, which is the advice, which is to try and open up and present the opportunity that will exist in a low carbon world, and help organizations understand that through footprinting, where we measure and certify organizations, their products and their services, and under the technology where we help to develop and deploy low carbon technologies and solutions. So the agenda, very quickly, we're just going to go straight into understanding the basics of the compressed air system. It's a simple enough concept. It's air which is at a higher pressure than your normal atmospheric pressure. As a working fluid, it is used as a way of storing and then transferring that energy to where it is required. It has many uses, as I'm sure you'll know. It's widely used because it is very versatile, and I can't think of any industrial businesses that wouldn't have a compressed air system in it, and it's used across a wide range of sectors. And when you realise that over 10% of the electricity supplied to the UK industry is used to compressed air, that gives you an idea as to the scale of the opportunity there is if you are able to make savings on your system. So the basic components of a compressed air circuit, the primary component is the compressor, which does what it is called. It takes in air at atmospheric pressure and then raises that pressure. The main areas for savings with the compressor are always going to come under good control and maintenance of that compressor. So once the air has been compressed, it then moves into the receiver, which is basically just a reservoir that helps the system to manage any variations in demand. After the receiver, then the air gets treated, so it goes through a series of filters or coolers and dryers. Their main aim is to improve the purity of the air. The degree to which you treat it is broadly determined by what you're going to use that air for. And then finally, you have the air line, which is just the distribution system that feeds the air from the receiver to where it's going to be used. There are a wide variety of compressors that are available. We've just to be simple, we've just represented 3 here of the most common that you would find. Typically, they would operate across a range of capacities. So you've got the piston and the reciprocating ones. Those have a wide range of use, as it says, from your hobby machine right up to the largest of the industrial machines that we would come across. You've got the rotary vane, again, ranging from the very small up to about a maximum of 75 kilowatts, which is still quite a big machine. And then you've got the rotary screw compressors. They're probably the most common that we would come across. And again, in industry, that they'll go all the way up to 500 kilowatts and beyond. So once you've compressed that air, you're then going to look to be treating it. Again, by the very nature of your sucking in external air and compressing it, there's going to be impurities in that. Least of all the oil that the air is going to pick up in the compressor itself. So I think the vast majority of compressed air systems you would have to have some form of treatment there. The treatment of it is energy intensive. It shouldn't be overlooked, and as a result, you should only be treating the air to the minimum level required. So say you're running a compressor in a garage for hand tools, you're not going to have to treat that to any great degree, but where you have compressed air operating machinery in a food manufacturing facility, then the treatment of that air obviously has to be to a much higher standard. So there's some main components that you'll probably recognise on your own systems. You've got the aftercooler, which is where you've generated the compressed air. It's a heat-intensive process. 90% of the energy that goes into compressing air is lost as heat. The use of the aftercooler then is to cool that air down. You can do that by a number of ways. It can either be via water jacket, and that water then can be taken off and used either for hot water at the site or for the process. More commonly, you would have an air-to-air heat exchanger. But again, that air then can be readily utilised if you're able to divert that into the factory or into the warehouse. Then that can help offset any heating costs. The water separator then is simply removes water or condensate before it then enters the air receiver. It just helps to dry out the air slightly before it goes into that storage component. The receiver it's just a big tank, and it's to provide some kind of buffering between the generating plant and the demand. It just helps with the control of the compressor as well. After that, then you're into the pre-filter and after filters. Again, these are just there to try to clean up the air and remove some of the particulates and the oil from the system. The dryer that takes the humidity of the air right down. They can vary in terms of their design and in terms of the dew point temperatures that they are going to achieve. Again, it's important to ensure that you're only treating the air to as much as you require in the process. The less treatment that you perform on the air, then the less expensive that's going to be. The most common are the refrigerated dryers, and they're actually, if they're well maintained, they're actually very efficient and relatively cheap. The larger systems would use the chemical dryers. Again, not overly expensive and can get the dew point down to as low as -25 degrees. The desiccant dryers, they are required if you do need the air heavily treated to a very low dew point. Again, you would come across that in I suppose food manufacturing would be the normal ones that I would say. They are expensive because you have to then dry off the desiccant once it's been used. So you would switch between either of the tanks there. While one is being dried, you would use the other one to treat. Less common would be the membrane dryers then. I'm not sure I've seen too many of them, but they're only for very small duties. So kind of in summary of the treatment and the associated additional cost, you can see where the costs begin to increase significantly, the lower your pressure dew point. So again, it's important to understand how much you actually have to treat the air. If you don't have to go down to that lower pressure dew point, then there's a very easy saving to be made on that. So areas where you'll go to find the savings. This chart has been this was constructed out of, I think it's over 40,000 Carbon Trust surveys over the years, and we've taken all of the recommendations from all the recommendations on compressed air systems. So you've, on the left-hand axis, you've got the percentage savings of the opportunity, and then on the right is just how common those opportunities are. The obvious one there is the leak reduction. They are every compressed air system will have leaks. I would have surveyed plants that would have, we would estimate maybe 30% up to 40% of the compressed air that they're generating there is being lost through leaks. They're very easy to find, they're very easy to fix. It's just organizations need to recognize that it's a very cost-effective saving that can be made. We would use a little ultrasonic leak detector. It's very simple to use, costs about £600 or £700, and I would say I wouldn't have surveyed a system where I haven't come across a leak that would have paid for the cost of the leak detection in under a year. other opportunities, there are the while there are big savings for the new compressors, they're not that common. Obviously, they can be expensive. The more realistic opportunities would be moving from a fixed speed machine to a variable speed compressor, where the compressor is able to ramp up and down in line with the demand, so that improves the generation efficiencies as well. We'll move on to the actual some of the specific opportunities. It seems obvious, but if you don't need to use compressed air, then you shouldn't. It's a very expensive medium to generate. So if there's an alternative to using compressed air, generally as a rule, that's going to provide you with a cost-effective saving. So moving from pneumatic hand tools to the electric alternatives, you're seeing a potential reduction there on 10 to 20%. Also, very often the likes of the pneumatic cylinders as well. So actuators, they're very often, if the same act can be carried out with an electric alternative, again, the rule of thumb is that should be done. And the use of compressed air for blowing off and for cleaning surfaces, etc., I would see that fairly commonly. It's a big waste as well. There are other alternatives to that, but it's very. I think it's very common because it's very handy. So we were talking about the leak reduction. Very common. I don't know that it's clearly understood just how much a small leak can cost over the course of a year. So we've kind of drawn a bit of a ready reckoner there to kind of equate the size of the leak with an actual annual cost. A 1.5 millimeter hole, but so you're losing about 150 litres a minute at 8 bar pressure, upwards of £1,000. As I said, we would use the little ultrasonic leak detector. You're going to find one of those leaks. That's the cost of that covered. Often, the easiest way to look for the leaks is to go in at a period when the plant isn't in production, and just charge the system up, and you'll be able to hear the vast majority of the leaks. So it's obviously a very cost-effective way to do it. It should be done on a regular basis. Certainly the ultrasonic leak detection, areas should be checked I would say every 6 months. So you would do that on a rolling basis, because if you're able to cut your leaks from 30% to 10%, that's going to be a big saving. So these would be the typical acceptable leakage rate that we would normally see. So with regards to the size of the system, obviously the bigger the system is, then the more leakage there's going to be. But on the other hand, you're going to have a higher tolerance as to the minimum leakage level that you'll accept. But as I said, the energy waste, it can be significant, and left uncontrolled, you're going to experience a drop in the system pressure. Your equipment's going to have to work harder, so you're going to shorten its life, and it's a waste of energy. The common problems is usually always going to be the couplings and hoses, and where you're joining the hose onto the snap fit couplings. The use of Jubilee clips is probably the biggest cause of leaks that I would see. They're not what you should be using to join the hoses up. There are, I think it's the 2-year compression type clips that are much better. You would also see holes in the or leaks around the glands on the pressure regulators, and or open condensate traps. We're going to touch on those in the following slides as well. Another fact to remember is for every increase in pressure of 1 bar increases your cost by 8%. A common question I would ask when I go to site when we're looking at the compressor systems would be to ask them, why are you at, say, 6 bar or 7 bar? Do you know what pressure your system can operate at? And the answer is usually, well, I don't know, because we've always operated at that pressure. If you're able to take that down by half a bar or a bar, and the system continues to operate without issue, then you should be doing that. Common way to do it is just to reduce it by half a bar. Don't be telling anybody you're doing it, because as soon as something goes wrong, it's going to be blamed on the pressure drop when it may not actually be that. So you just continue to take that down over the course of a number of weeks, and if you're able to eke out a bar or a bar and a half, then there's a very easy saving to be made. To improve the pressure, there's a handful of things you can do. Make sure you keep the sizing of the pipework as large as you can. Don't be or remove any bottlenecks or obvious restrictions, any joins from the larger ring main to some of the processes, and if you've any old redundant piping, make sure that that's sealed off from the main system. Obviously, when areas or machines aren't in production, they should be isolated, and that can either be done manually by the operator, or it can be by a little solenoid valve that's linked into the power supply to the machine. So when the power goes off, then the compressor system is isolated. That helps a lot with leaks as well. If the machine isn't on the system, then it can't leak. So, there are a number of methods that the compressors are controlled, and there's areas there that where improvements can be made. Just your normal start-stop control, and that's going to be very small machines, so your hobby compressors or ones in a maintenance workshop or something like that. But you generally can't do that on the larger motors. Common would be the throttle control, but it's once you drop below that's 70 in terms of operation, then that becomes an inefficient method to use as well. So you would use a throttling control on a machine that was generally was providing the base load to a plant's requirement on a machine that's generally running flat out. Load and offload control, again, that would be widely used where the machine continues to run, but only then cycles between its full load and zero load as and when the demand is made of it. The best type is where you're going to use variable speed control, where the speed of the machine will ramp up and down as and when the demand on the compressed air system increases or decreases. So see, while the variable speed drives are slightly more expensive than your fixed speed machines, you can see that in terms of the lifetime savings that are generated by it, it by far and away outweighs that additional cost, and because the machine isn't operating at its peak capacity all the time, then you also save on the maintenance and service costs as well. We're going to go on to talk about the energy technology list as well, and there's an opportunity there to help to offset that increase in purchase price anyway, as long as you're looking at a machine that's listed on that list. If you're running a system that has two or more compressors, then you should be looking at a master controller. This kind of takes all the guesswork out of which machine should be running when and how. The system will learn from your system, and it will help then to select the most suitable compressor to meet the demand. So it'll select your fixed speed machine, obviously, always to cover off on the base load requirements, and then we'll bring in and ramp up and down the VSD as and when required, just to cut off the peaks there. I mean, the simplest types are relatively simple, relatively cost effective, and if you get it right, then you're looking at quite significant savings there as well. But to talk a little about the opportunity for waste heat recovery. Again, depending on the compressors and depending on the pressure that you're generating to, the air exiting can be, it's upwards of 80 degrees, and for the higher pressure machines up to 170. So the way that air is cooled then depends heavily on the temperature, but typically where you're using air, that can be used, as I said, to offset the heating requirements in the factory space or warehouse, and it's a simple case of installing the ducting and the bypass. Obviously, you're only going to want to use that air during the summer or during the winter, and during the summer months, then you can allow that to vent to atmosphere. Very simple, very cost effective, and that would be a common recommendation that we should see. Just on that, you see that that the diagram there has the external air been ducted into the compressor. Best practice for that would be to duct the air from external so that it's as cool as it can be. The cooler the air that you can introduce into the compressor, then the higher the efficiency of the compression process. It would be very common just to see a compressor in the compressor house, and it's hauling in the warm air that the machine is exhausting, as opposed to having the warm air taken out of that space and the cold air brought in from external. So it's just one to remember. So for the higher temperature machines, you see the picture at the bottom there. Those are machines that have been water cooled. So the use for the warmer or the warm water. Very often the water one, you would use it to preheat boiler feed water. I've seen them used to generate the vast majority of CIP water requirements in the food industry as well. So big opportunities there, and taken at its simplest, it's quite a cost-effective project to look at. Condensate valves, they're used to remove the water to remove the water from the system that has condensed out. There's a variety of ways that this can be done. It's rare to come across it now, but often there'd be just a hand valve at the bottom of the receiver, and one of the maintenance guys swings around 3 times a day and cracks the valve open for 10 or 20 seconds. Again, you're wasting the air that you have generated. More commonly, it would be by the timed solenoid valve, which is represented there. They're slightly better than just an open valve, but they're often incorrectly set, so they're going off too often, or they're going off for too long, and they aren't able to alter when they open, as the demand on the system moves up and down. Obviously, you're going to produce more condensate the more demand that's made on the compressed air system. And what you often find with them is that they'll go faulty reasonably quickly as well, so you end up with them either not opening or staying open. That one on the bottom there, that's I think I took that photograph. That's at a sawmill, and that valve had just stuck open, and you can see from the oil on the ground and on the wall where the spray has been impacting on it, and that's been like that for weeks, if not months, and it was just ignored. So if you're going to do it right, we would recommend that you use the no loss type electronic condensate drains. They operate using an upper and lower liquid level, and as such you do not waste any compressed air using these. They're becoming a lot more common in the last sort of 3 to 5 years, but I would still see a lot of the timed solenoid valves being used. So if you have them, get them changed out and get them onto the no loss type. This was a pressure problem. They were between where they were generating and the back end of the system. They were beginning to get quite a large pressure drop that was causing problems in the system. I think one of our surveyors went in and was able to identify just areas where things were becoming constricted. You know, there were pipe size reductions, etc. And you know, I think we'd a range of recommendations that they quickly implemented. So they were able to reduce that pressure loss, and I think because of the scale and the pressure that they were operating at, even that small reduction in the pressure drop was saving £9,000 a year. So again, it's a problem with systems that are often overlooked. As long as you're hitting the pressure that you need, then you know that's fine. It doesn't really matter how you do that when actually it does. There is a significant saving to be had. Same company where they were using compressed air. I think it was probably to dry, which would be fairly common. You would see compressed air being used directly in food production as well to dry. Very often it's just an open hose or a squeezed down end of the hose. That's hugely wasteful. Where you can simply fit one of the more air efficient nozzles, which will drastically reduce that air loss, and they're relatively cheap. So if you have any open-ended compressed air use, then I would say that you should be looking at the opportunities that the air efficient nozzles will afford you. So once you've had a look at your compressed air systems and you've identified where the opportunities are, then the Carbon Trust is able to help with the capital cost through the Green Business Fund. It's currently open to small to medium-sized businesses in England, Scotland, and Wales. The timescale for that being offered is limited. It's not going to go on. It's hugely successful at the minute. So the funds are being rapidly used, which is great to see. But if you do have any projects on your books, I would advise you to get on with them. The fund at present can provide a combination of direct advice and training, and of course the direct capital contribution on the capital cost of the equipment. As I said, is available England, Scotland and Wales, small to medium-sized businesses, schools, sole traders and charities. And that's the definition for SME that qualifies you. All of this is available on the Carbon Trust website as well. I'm going the wrong way. So some of the services that have been offered out under the Green Business Fund. There's the option for the 2-hour workshops that are going around the country. They're usually hosted by a Carbon Trust partner, but the delivery is by the Carbon Trust. So it helps organisations and individuals understand their energy consumption, and then looks to help you identify known low-cost measures. And I think that's they're ongoing. And again, the details of those are going to be available on the website. The opportunity assessment, this is an area of it that I would be mostly involved in, where we would provide a remote or on-site energy assessment and audit, and we look to focus our attention on the top 3 costed recommendations. We then outline how you should take that to the next steps towards implementing and actually realizing the savings, and that would be available again for SMEs in those qualifying areas, again, England, Scotland and Wales. Again, implementation advice is an area that I would be strongly involved in, and this can offer up to 5 days of support. It's ideally, we're looking for companies that have a business case for the projects ready, and we would typically help with the production of the tender documentation, and we would then offer that out to a selection of suppliers from our Green Business Directory, and then we would help in understanding and quantifying the tender returns as well. Again, this is proving to be very popular offering as well, across a wide range of projects, from LED lighting to compressors to the likes of extruders and all sorts. So if there is a project there that has a readily identifiable energy saving, then we would be happy to help. Over to my colleague, I think, aren't for the ETL.
Hello, I'm Kay Rolton from the Energy Technology List team. So very quickly, a slide here about the scheme. It's a government-approved list of energy-efficient products. So under the category of compressed air, we have flow controllers, master controllers, refrigerated air dryers with energy-saving controls. In total, we cover about 57 technology categories. So organisations that pay income or corporation tax are able to claim enhanced capital allowances on the purchases of those bits of equipment. So what does this mean? It means that they can get all the tax benefit in the year of purchase. So for example, if an organisation is spending £10,000 on the purchase of equipment that is listed on the energy technology list, the benefit to them could be what was the corporation tax rate of 20% equates. It varies according to what the standard rate of corporation tax is. We do, as well as things like compressed air equipment, we do have other technologies, particularly popular lighting. They're not listed because there are too many variations, but enhanced capital allowances can still be claimed if the manufacturer can demonstrate that their lights meet the ETL criteria. I'm only going to run through this very quickly so that you can then, there's a link there to further information about the scheme. There's information for purchasers or information for manufacturers as well, relating to what is needed to support a claim for these categories. Thank you.
Okay, thank you. We're going to talk a little bit more about the Green Business Directory. It's an offering that the Carbon Trust has put together in recent years. I think that we recognised that there was a demand for a directory of businesses in that the energy reduction sector. So if you're looking to install energy efficiency projects, now this can be across all aspects. So it can be your LED, it can be your variable speed drives, it can be extraction systems, it can be heating systems, then, or even renewable technologies. Then you can access the Green Business Directory. It helps because the suppliers that are on it have gone through an independent verification of their claims, so they would make an application to the Carbon Trust and submit a handful of case studies. These are followed up with the companies who the case studies are on. So we're making sure that the claims that are made are true, and they also go through a technical interview just so that we can assess their credibility and their capability. And there are obvious benefits in that. You know, it's helping to close the gap, you know, between the lack of customer understanding. It helps with knowing that you can trust the claims that are made because they've been independently looked at, independently verified, and they've gone through what is a quite rigorous process. Anybody can access it. It's online. It's easy to search. You can search by region. You can search by supplier if you want. You can search by the technology that you're wanting to implement. That's us. Questions, answers, comments?
So Donna, the first question we have comes from Paul Busfield, and he's asking, you mentioned ducting external air to the air compressor. Does it matter if the external air temperature is sub-zero?
No. The colder the better. The colder the air, then the denser it becomes, and as such, for every stroke of the compressor, you're actually hauling in more air, and it then improves the overall efficiency of the compression.
Our next question comes from Tom Vitch, and he says, what is the best way for a company to identify if their current compressor is oversized and they could replace it with a smaller one?
That's a good one. It's probably easiest way is to do some logging of the system. If it was me, the easiest way to achieve that is to ask one of the suppliers in, and they, if they're any good at all, then they'll be more than happy to strap on some analysis equipment, and then they'll very readily be able to tell you what the best fit is going to be. That's a fairly common route that we would see projects coming through onto the Green Business Directory, is where organisations have asked the suppliers in, and again, any of the suppliers that are going to be worth anything are going to happily do that for you, and doesn't cost you anything. It's even better.
It doesn't seem like we have any other questions, and we have actually run out of time. So just to say thank you again to Donald Moorhead, and thank you to everyone for attending to today's webinar. If you do have any further questions, please do not hesitate to contact us via greenbusinessfund@carbontrust.com. Alternatively, you can call us on 0207 832 4773. On behalf of the Carbon Trust and our presenter, thank you for joining us today, and enjoy the rest of your day.